This is CPM Precalculus Chapter 3, number 76. So Joe has hooked up two function machines as shown in the diagram. So here are two function machines. Here's one of them. Here's the second one. When he puts 4 into the 3 to the input machine, so here's the 3 to the power input machine. So if he puts 4 into it, right, there's the input, 81 comes out. So plops out is 81. Okay. Then 81 goes into the log base 3 machine, and 81 goes inside. Okay? And that's because 3 to the input basically does 3 to the power of whatever the input is, which here is 4. 3 times 3 times 3 times 3 is 81. So that's the output. Okay? It just gives us an overview of what these machines do. So let's go ahead and talk about, well, what is log base 3? Okay, because what comes out of the log base 3 machine when 81 goes in? So here we have 81. It's going into the machine, and what comes out? Well, let's go ahead and write this. This is log base 3 of 81, right? Since 81 is going in, log base 3 of 81 equals to what? So what is coming out here? Well, we know, let's go ahead and set that as a variable y. We know that's equivalent as writing 3 to the power of y is equal to 81. Okay, so what is y? Well, 3 times what equals, 3 times itself, how many times? 3 times 3 times 3 times 3 is equal to 81. So we know y has to be 4, right? So y is equal to 4. Right? So what comes out? 4 goes in. We take 3 to the power of 4. We get 81. 81 goes in. We have log base 3 of 81. And 4 comes out. Alright? Let's go on to part B. So now we're going to do something different. Let's put 2 into the first machine. So let's use green. And I'm going to start with 2. What number comes out of this machine? So we know what comes out of the machine is 3 to the power of the input, which is 3 to the power of 2. Let's write that here. 3 to the power of 2 is equal to 3 squared is 9. So let's write it here as well. So that's the first part, right? First part of part B says what number comes out of the machine? 9 comes out. Finally, the number that comes out of the machine goes into the other machine. So we put 9 into the log base 3 machine. What comes out of the log base 3? Well, log base 3 of 9. What comes out? Let's call that variable y. And we know that's the same thing as 3 to the power of y is equal to 9. And here we can see, well, 3 squared is equal to 9, so y has to be equal to 2. Right? So what comes out of the second machine is going to be 2 here. Okay, so this part B has two answers. The first part is 9, the second part is 2. Let's go on. Let's go on to part C. Part C says, well, let's go ahead and bring this down as well because I have the image here again. What if x goes into the 3 to the input machine? Well, y comes out. So if we put in x here, the output here is y. Okay, so 3 to the power of x, right? The input is x. Y comes out. So that's equal to y. Well, if y then goes into the log base 3 machine, so y goes into this machine, what comes out here? So what's coming out is basically, well, let's go ahead and do this. If we have y going in there, we're going to have log base 3 of y, and we know that's the same thing as log base 3. Well, y is equal to 3 to the x, so 3 to the x. And what is that equal to? We know whatever this equals to, let's use z since we don't want to use x and y, they're already used here. This is the same thing as saying 3 to the power of z is equal to 3 to the x. So what is z? Well, z is equal to x. So what comes out? x comes out of the machine. If you put x into this one, 3 to the input, so 3 to the x, you get y. Well, if you plug in that y here, you get x. So isn't that interesting? You plug in x, you get y. You plug in y, you get x. Okay? And note that these do different things. This one does the exponential, 3 as the base. This one does the log with 3 as the base. Okay? Let me go ahead and clear this a little bit. So we know here output is x. I want to erase this so we can go ahead and see this problem. So now if x goes into the log base 3 machine. So here instead of some part D, let's plug in, let's use a different color. Let's plug in x into this machine now. Y comes out. So log base 3, if x is the input, y comes out. Okay? If x goes into the log base 3 machine, so log base 3 of x, y comes out. Write this in mathematical notation. Well, there it is right there. Right? This is the mathematical notation. Log base 3 of x equals to y. Let's go on to part E. If the same y goes into the input, 3 to the input machine, so now we're going to plug this blue y in to the input here, the original x comes out. Write this in mathematical notation. So that's saying 3 to the power of y, which is equivalent to 3, since it's the same y as this problem part D, 3 to the power of log base 3 of x. It says the original x comes out is equal to x. So this is the mathematical notation to actually write this down. Okay? You kind of have to just go and look closely. Well, 3 to the input means whatever goes in as the input, you replace it as 3 to that input. Okay? So that's the mathematical notation. Let's finally go to part F. Do your answers to part D and E say exactly the same thing? Well, let's look at it. D says log base 3 of x equals y, and E says 3 to the y is equal to 3 to the power of log base 3 of x is equal to x. Do these say the same thing? Well, right away, are these equivalent? Question mark. I mean, they don't look like the same thing, but are they? Because in mathematical notation, we know the definition of logarithm. Remember, the definition of logarithm says if if b is greater than 0, right, then log base b of x equals to y. That's the same thing. That's equivalent to writing b to the power of y is equal to x, right? This is the definition of log. These are two equivalent statements, right? Well, are these the same? Well, instead of b, what's our base? 3. So let's go ahead and say that. If 3 is greater than 0, right? So we have b is equal to 3. That's true. 3 is greater than 0. Log base 3, right, of x equals to y. Well, what's the equivalent of this? That's the equivalent is 3 to the power of y is equal to x. And is that what we're saying here? We're saying 3 to the power of y is equal to x? Yes. So are these equivalent? Yes, they are equivalent. Right? Parts D and E are the same thing, based on the definition of logarithm. And there we go. So that's going to end for us CPM Precalculus Chapter 3, number 76.